Ever imagine inspecting a whole highway system, not from a car, but like up in the air, like with drones? That's what we're diving into today, using drones and AI to, detect traffic signs.
Yeah, it's a fascinating new area. You've got infrastructure management meets cutting edge AI. It's really pushing past what we could do with just like, you know, manual inspection.
So no more like inspectors stuck in traffic with clipboards.
Exactly. This research, it really dives into how drones equipped with AI can capture those images, and then the AI analyzes them for, like traffic signs, and it speeds up the whole process so much, and it could even be more accurate potentially.
And this system they're using, it's called Faster RCNN. Can you explain how that works?
So imagine the AI is kind of like quickly scanning for anything that, stands out. And then it focuses all its attention on those areas, like really honing in to figure out what they are. And that's kind of the essence of how this faster RCNN works. It's not just like recognizing shapes, right? It's got this two-step process where it proposes regions that are likely and then classifies what's actually in those regions.
Oh, it's like the AI glances around for anything interesting
Yeah,
and then puts those specific areas under a microscope.
yeah. A very good analogy. And to make that initial scan even more efficient, they use these things called anchors. Think of them as like visual guides or even templates for, common shapes and sizes of traffic signs.
That makes sense. It's like saying, okay, most stop signs are this big in this shape. Let's, focus on anything that looks like that.
Exactly. But as with any AI project this ambitious, the researchers, well, they ran into some challenges, mainly with the data used to train the AI.
Well, yeah, it wouldn't be a real AI project without a few hurdles. Yeah. What was the main obstacle?
Data. Or, well, more specifically, the lack of it. See, but train an AI model for something this complex, you need a ton of data. And they just didn't have enough real-world drone imagery, especially for certain types of signs.
Why? So what did they do about it? How did they get past that?
They got creative. They turned to simulation. So they used this drone flight simulator, AirSim, and this video game engine, Unreal Engine, and they used those to create realistic training data.
Hold on. They trained AI using a video game. That's wild.
It is. And by creating these virtual environments, they could generate so much data, and they could label it, simulate all kinds of weather, lighting, even different drone angles.
So it's like building an entire world, but just to teach your AI.
Precisely. But this really innovative approach, it revealed a key limitation of AI. Like, there's this gap between simulation and reality.
Ah, so it works perfectly, in theory.
Right. The AI was amazing in the simulation, but when it came to real-world images, it struggled. Like, it could detect these things called New Jersey barriers in the virtual world, but in real images, not so much.
So even with all that simulated data, the AI needs real-world experience. To really learn and adapt.
It does. It needs that real-world grit, you could say. And that just underscores how important it is to ground AI in reality if you want it to really work well.
Were there any areas where it did really well, despite that challenge?
Yeah, actually, it was remarkably good at detecting speed limit signs, in real-world images even.
Why do you think it did so well with those, even with potential like distortions or weird angles?
That's a good question. It's probably because speed limit signs have that very distinctive shape and the colors are very consistent. Makes them easier to pick out.
So even AI has its strengths, right? It gravitates toward those really visually distinct elements. But this is more than just seeing a sign, right? You mentioned geolocation. How does it go from I see a sign to this is exactly where that sign is?
Okay, so it combines the drone's GPS data with information that it's pulling from the images themselves.
Interesting. So how does it actually pinpoint the location?
Think of it like triangulation. So the system analyzes the sign's position, but within the drone's camera frame. And it factors in the drone's altitude, the camera angle, all of that. Yeah, exactly. With all that, it can pinpoint the sign's location on a map.
Well, it's like the AI has its own little GPS system almost.
In a way, it kind of does. And this is what I think is so cool. It's not just about detecting. It's about getting, like, actionable insights. Imagine having these automated infrastructure reports with, like, precise GPS coordinates for every single sign, categorized, and even flagging potential issues.
That would be huge for, like, the crews that actually have to go out and do the work. Giving them that level of detail, accuracy, that was basically impossible before with just someone driving around writing stuff down.
Absolutely. This tech could totally change how we do infrastructure management, make it way more efficient, cost-effective, and yeah, way more sophisticated even.
It really opens up so many doors. And not just for infrastructure, right? I mean, anything that uses visual data analysis like search and rescue, environmental monitoring, even agriculture could benefit from this.
Exactly. This research really highlights what AI can do. Automating these complex tasks, pulling out really valuable insights from visual data across all these different areas.
It's amazing work. But like any tech this powerful, especially as it keeps getting better, we have to think about the implications, right? What are some of the limitations we need to keep in mind as this technology keeps developing?
Well, we already talked about the whole simulation versus real world data thing. And something else is that we need to develop AI models that are, I guess you could say, more robust, more adaptable. Like, remember how it struggled with those New Jersey barriers in the real world?
Right.
We need AI that can generalize better, so it can handle variations, in appearance, lighting, even just the context of the image.
So it needs to be more adaptable, more street smart and less textbook smart, maybe.
Precisely. And then there's scalability. This research was all about traffic signs, right? But
Hmm.
imagine expanding that to, like, identify all sorts of infrastructure problems. That's a lot of data. It takes a ton of processing power, and the models need to be really sophisticated.
The big jump to go from, identifying one tree to analyzing the whole forest, I guess.
Exactly. And as we scale up, we also need a way to manage and make sense of all that data. It's one thing to say, hey, there's a pothole. It's something else entirely to analyze thousands of images, figure out which repairs are most urgent, and maybe even predict what problems are going to pop up next.
And that's when things get really interesting. Moving beyond just identifying
Yeah,
to proactively managing and even predicting problems before they happen.
exactly. We're not quite there yet. But this research, it gives us a peek into the future of AI-powered infrastructure.
It does. There's one more thing I wanted to touch on. You mentioned how the AI can tell different traffic signs apart, right?
Mhm.
Did they find any differences in how accurate it was depending on the type of sign?
That's a great question. And it actually gets back to our recurring theme, data.
So even in the AI world, data is king.
Hmm.
Huh. What were some of the differences they found with those signs?
So the AI, it was really good at recognizing those signs with the really clear shapes
Hmm.
and colors, but signs that looked alike, especially if they didn't have a lot of data to train on, those were
Yeah.
tricky.
Right.
It's kind of like if you're teaching someone about different fruits, right? If they've only ever seen a red apple, they might not know what a green apple
So
is.
even AI has its limits.
Right.
It's the less obvious stuff that trips it up, which makes sense, but it really highlights how important it is to have that good data,
Yeah.
diverse, and a lot of it.
Absolutely. It's not enough to just throw data at the AI. It's got to be the right data that reflects those real world scenarios.
This research, it feels like a starting point, like a peek into what's possible with AI and drones. What do you
Yeah.
think is next for this kind of technology?
I think it has the potential to completely change how we handle infrastructure. I'm imagining a future where AI is doing all the hard work, right?
Mm,
Analyzing the images, finding the problems, making the reports, and then the human experts, they can focus on the stuff that really needs, a human brain, that critical thinking, the decision making.
a true partnership, right?
Yeah.
Using the best of both worlds. That's really exciting.
It is. This research really shows us that at the end of the day, AI is a tool, and it's
Wow.
only as good as how we, design it, train it, and make it work with the systems we already have.
It's a powerful tool for sure. One that could change how we manage, well, not just infrastructure, but tons of different fields.
Yeah.
It's been so interesting diving into this world of AI and drones and the future of infrastructure. We've covered a lot, from how object detection works to the bigger implications of this tech.
We've only just scratched the surface. This technology is going to keep advancing, so we can expect even more amazing applications, groundbreaking discoveries even.
It's an amazing time to be, well, alive,
Hmm.
to see this tech evolve. For our listeners, if they want to learn more, stay ahead of the game, what should they check out?
I'd say dive into the world of AI, see how it's being used, and keep an eye on, the ethics of it all. That conversation is super important.
Such great advice. Stay informed, stay curious, and hey, maybe you'll be the one developing the next big thing in AI-powered infrastructure. Until next time, thanks for joining us for this deep dive.